All right, welcome back, everybody. We got 2.4 parameters, arguments, and return statements. This is a lot of stuff, but it's really going to bring us full circle on functions, okay? So diving into it, here is the problem, okay? Up until this point, you've only learned void functions, although we can kind of see with our main function that it has had a return type this whole time, but we haven't been able to share information between functions. When we created a variable in a void function, that was the only place that it existed, okay? Well, in order to share info, you had to do some global variables, right? Which is not the end of the world. We have global variables for a reason. You put something on the main scope of the file. And then when we get input in one of the functions, we store it into that global variable so that when we go to print input, sorry, it's being blocked there, that we can still access it, okay? However, to rely on this going forward is going to pollute the global namespace, okay? So we want to be able to share info between functions, and we also want to be able to get info back. That's what this lesson is really going to focus on. So first, we're going to start with just the sending of information to functions, okay? And that's where these two words, parameters and arguments, are going to come into play, okay? A parameter is a list of all variables or data that a function can receive. You must state the data type and name. The order matters. Okay, so where do you do that? That's right here. When you create a function, up until this point, you've done parentheses here, right? Well, now whatever you list between those parentheses, you're saying is the data needed for this function. So it'll take an int, and we'll call it x, and it'll take another int called a y. This is where it's called parameters, okay? Now, a key part here is if you list parameters, that function has to take parameters. You cannot ignore those now, okay? Now, the other term here is arguments, the actual data being sent to the function. The order must match the listed parameters. So we have two examples of functions. Now, I did these examples a little different. I did this one with just using the data, 3 and 5. And you can see it's separated by comma. And then I did this one with variables to kind of show you that we can put a lot of different stuff there. It's not just the raw data. So when we called the function add now, we sent it to 3, we sent it to 5. It goes boom, right here. So this would be a 3, this would be a 5, this would print out an 8. And then here it would be a 2 and a 10. So this would be a 2 and a 10. And that would be a 12 now, okay? So this is how we send it, all right? Now, the key part of understanding this is a term called pass by value, okay? Sorry. There's another term really called pass by reference. What's the difference, right? Pass by value is when sending arguments, only a copy of the value is sent, not access to the actual variable. And what that means is here, we create an int called x, right? We set equal to 10. We sent it to this function called increment. Now, I know we just could have called x++ before, but that's not the point. The point is we sent it to a different function and wanted to increment it there. And then nothing else happens in increment. We go right here, we try to print out x, okay? And the question you have to ask yourself, does this x print out a 10 or does it print out an 11, right? Because it was incremented in that function. So we're going to do this example as we learn how to list parameters and send arguments and test out what that answer would be, okay? So let's do that right now, okay? We got our our Visual Studio Code up here. I don't know why that's coming in so interesting. Okay. And, silly me. Okay, now we're back. Oh, wow, that's from the old code. Let's clear that out. Okay, now we're ready to go. Let's do some of those examples. So I'm going to list, a couple functions up here. We're going to do the void increment function that just takes an x, right? So we're just defining the functions that we're going to have. And let's do another one. Let's do a void, and let's just have this one print, all right? And, I'm trying to keep this simple because I really want to focus on the parameters. So we're going to list 3 different parameters. We're going to list an int a double b, and a string c, okay? Now I'm doing it this way because I want you to see that we can have whatever data types we want in whatever order we want. but I'm listing this as an int and then a double and then a string. And so when I call print, I have to send all three of those. Okay, so let's define these. Let's first define the increment and let's test that one out. Let me minimize that. Okay, so we're going to define increment, which takes one integer, and we're just going to increment it 1. Okay, now in our main function, we're going to create x equals 10, right? We're going to pass it to increment, and then we're going to try and print out that x value. And let's observe what happens here. Okay, so let's do this. Okay, we'll give it a compile and let's give it a run. Okay, and just the value 10 printed out. And that's crucial here. Okay, this x is a different x. Okay, and this is what's called pass by value. The access to this x variable in main is not being sent. We're not changing this variable at all. We're just passing it the value of it. So we're passing it a 10, and then 10 got turned into 11, but then because this function ended, it didn't even matter. Okay, so that's kind of a key aspect here. All right, now let's also look at print. So void print, we're going to go an int a double b, a string c, right? And we're just doing this to kind of test out some errors here, okay? And we're just very simply, we're going to go, here's the int, right? And we'll print out the int. And then we're going to do this 2 more times with the double and the string, okay? And what my intent on this example is to show you that order matters, and to B, show you what happens when you don't respect that order. Okay, so all this will do is print out the A, B, and C. So I'm gonna comment this out because that was for the other example. All right, and I'm gonna call print. So I'm gonna call print, and I'm gonna pass it a 3, a 3.14, and then in double quotes, because that's what strings are, and pass it hello, keeping it nice and simple. All right, I give this a compile, I give it a run, and you can see here's the int 3, here's the double 3.14, and here's the string hello. Okay, now watch what happens when I don't respect that order, or maybe I leave one off. Let's leave off the string here. Okay, and let's see what happens. Let's give it a compile, give it a run. And sorry, okay, I shouldn't have given it a run because that was the old one that worked, right? Because this new compile failed. And you can see right here, too few arguments to function, void print, blah, 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 right? It needs to take all 3 of these in the order of those matters. If you say int double then string, then it needs to be int double then string, and you cannot leave any off. Now, when you get down the line further in C++, there is a thing called defaulting. We're not going to cover defaulting right now. We're going to kind of save that a little bit later when we're working on classes. Okay, so there is kind of a way around that issue that we just saw. But we're going to table. Yeah, we're going to table that one. Okay. All right. Let's see. I think we're pretty good on sending information. I just want to cover one last thing. When you send the actual info, it's called arguments. When you're writing the function header here, it is called parameters. We're really talking about the same thing. We're talking about a different side of it, right? The sending is arguments, the receiving is parameters, okay? All right, let's get back to it. Okay, so returning information. So returns, this is kind of going to bring us full circle here, right? So we just saw how to send information to a function, and now we want to be able to return information from a function. Now you've seen this kind of done already, right? Instead of void for the main function, we had int, and you always saw a return 0 at the end to let the system know that the program ran successfully, right? Well, now we're going to be doing that ourselves. So instead of void, you put the return type here first, right before the name, and that will be whatever information you're trying to return. So if it's an int, you need to put an int. If it's a string, you need to put a string, and you have to respect that type. And if you say there is a return, so if you put int, then that function must return something of int. You cannot now leave the return statement off, okay? Now, in fact, I don't even think I read this. Functions, a set of return type must return a value that matches the data type. Instead of void, you'll list the data type before the function name. So I basically said that. Here's something crucial though. Return statements exit functions, okay? So when a return statement runs, no code after it will run. It'll return control back to where it's called. So let's look at this code. We have int result is equal to add 3, 5. So 3 and 5 go here, right? And notice how in the return statement, it returns 3 plus 5, which is 8. So this information, this return, goes all the way back up here, right? And it replaces this. So this would now be 8, and then 8 would be equal to result. Now, you don't always have to do that, right? Here we're setting a variable equal to the return of this function. You could also just call it as you're trying to print it out, right? You can do a lot of different things with this, okay? Or you can even put this, in here, and the return statement would be sent to another function, right? You can do all sorts of crazy stuff, okay? Now look at this one, right? Here we're calling get input, and I love this function because it simplifies C out so much, right? Especially when getting input. Look at this. We have a function called get input. We sent it to phrase, enter a word, please. That goes here to this parameter request, and then we print out that message. So, the way this function is designed is you send it the message you want, it prints that out, it stores the response. Man, wish I figured out how to get this thing to go away. And then it'll return what the user said. So now, whenever you want to get something from the user, you don't have to write those 4 lines. You can just make a function called getInput that returns a string, takes a message. You call it here, and whatever the user typed in will now get stored in this variable. Functions help us simplify things we're going to do 100 times, right? Okay, so now we have another example. Okay, so I have some code up here, just a little bit of stuff. We're going to need a little bit of CMath here, and we're going to do something called check the discriminant. Okay, so if you remember with the quadratic formula, you had the b squared minus 4ac that was all under the square root, and it told you how many solutions there were, right? If you had a positive discriminant, you had 2 real solutions. If you had a negative discriminant, you actually had imaginary solutions. So we're going to write a function that checks that discriminant and returns a true or false if it works. And if it works, then we'll actually run the discriminant and print out the number that you get. Okay, so we're going to do check discrim, and then we're going to do double, and we'll just call it discrim. I'm just going to take an A, a B, oh my goodness, and a C. Okay, so let's start defining these functions. All right. Now the reason why I'm splitting these up is because it's good practice to logically separate things into different functions, so that if an error goes wrong, you can really pinpoint it down to a specific function. So notice how I set a return type of bool for this. I'm going to return a true or a false, okay? So I'm going to go double discrim is equal to, now the discriminant, you take the power of b, so b to the power 2, so I'm going to go power of b squared, and then you minus it by 4 times a times c, okay? And I'm going to check if that's greater than 0. So if the discrim, and in fact, really if it's greater than or equal to, because if it's 0, we still have real solutions, and we know that maybe we can go forward with the quadratic formula. So we're going to go greater than or equal to 0. If it is, we're going to return true. So now we have the A-OK to do it, or if it's not, we're going to return false, so that we shouldn't do that, okay? All right. Now the next part is the actual discriminant, right? So that's double discrim, and it takes an A, takes a B, and it takes a C value. And it's going to be very, very similar, except for I'm just going to go right ahead and return that discriminant, okay? So I'm going to go return, b squared minus 4 times A times C. Now, you might be thinking, why didn't I just put these in the same one, okay? The reason why I separated them is because if I do my checks separately and get that true or false, then I can proceed to actually write it, calling the code to get the answer. If I don't check it there and I check it in the discriminant and I don't have the appropriate A, B, and C numbers, Well, how do I get my control back to the main function? Because we said we're returning a double and it has to return a double. So if you try to put in a secret number that you can check, like a -1, well, what if the discriminant equaled -1? How do you actually know that's what it was supposed to be? So we're going to do our check separate so that we can keep the control flow where the user is, okay? So let's do this. Let's get our numbers from the user. So, enter 3 doubles, okay? And then let's make those. So we need A, B, and C. And then we're going to store them just like that, okay? And then the first thing we're going to do is check the discriminant. So I'm going to print out the value, okay? So that I can see if it works, right? Now we're going to pass A, B, and C right there. And let's give this a test run, all right? Hopefully there's not too many errors. We wrote that kind of in one fell swoop. Look at that, it ran. You can see I've done some testing before. And so 2, 5, and -3. And you get 1, all right? Now, why did you get 1? Remember that bools, even though we know them as true and false, it's really 0 and 1, okay? So a 0 is a false, a 1 is true. So by using 2, 5, and -3, we know we get a positive discriminant. That's true, right? We're gonna get a number greater than or equal to 0. So we see that 1, okay? So now that I know it works, okay, I can call it, but our program doesn't really know it works. So let's do this. If check discrim, okay, and I pass it to A, B, and C. And now look at this is actually really kind of cool. I'm using a function inside of an if statement, right? It only can do this because it returns a bool. So that's another important part about separating your check discriminant into a separate method. I can use it with an if statement. So if it is, watch, I call the discrim, right? Well, it returns this. I'm going to print it out. So, the discriminant, oh my goodness, is, and then I'll call it. Okay. And then if it's not, right, if that doesn't give us true, then I'm going to return, the numbers you gave didn't work. Okay. Let's give this a new compile, a new run. We get our numbers, 2, 5, -3. The discriminant is 49. Okay, so that worked just how we wanted it to. Awesome. Okay. Let's try and just pick some numbers. Let's do 1, 1, 1. Let's see if that gives us a quadratic. The numbers you gave didn't work. So an A value of 1, 1, 1 is not going to give you one with real solutions. Okay. So let's just do a little quick recap here. All right, because this was about returns. If you write a return, right, if you state that a function has a return, you need to return a value. Now look carefully at how this is structured. I do if something is true, I return a statement, right? And notice how my very next one is an else. When I do that, it's a guarantee that either the if or the else runs. 100%, one of those will run. And so that means 100% of the time, I will get a return statement, okay? Let's just say I deleted this, right? And this was my function. Well, there's no guarantee that this runs. That could create an error because something crazy might get returned here. It might try and pull something else. So you need to make sure there's a guarantee that if that function runs one way or another, there will be a return statement, okay? And I highly suggest starting to do this. Now that you can share information between multiple functions, you can send info, you can return info, it's time that you start logically separating everything into functions, okay? All right, let's get back to it. Function overloading, okay? I think this might actually be our last concept. Interesting, or one of our last concepts. So function overloading is important, right? As you can start to see, it might be helpful to be able to use the same name for a function sometimes, right? So function overloading is using the same function name, but using a different amount of parameters to differentiate between the two for the compiler. This allows you to write a function that achieves a similar goal, but needs a different amount of inputs, okay? So if you look here, right, we made two functions with the same name, which normally we cannot do, okay? The first one has 3 parameters. The second one has 4. That's how the compiler is going to know. When you call add and send it 3, it knows I need this one. when you call add and you send it 4, it knows I need this one. Okay. So let's do a very brief example of that. So let's delete this code and just kind of start with a fresh file here. Okay. And I think I might just use, add, but with doubles. Okay. So I'm going to do my function header. So I'm going to go double, A, double B. I'm just going to do 2. And this is the time to kind of show you some complicated C++. You technically, when you do the function header here, you can just do this. Okay. All right. When you actually define the function, you have to give those names. But when you're just declaring that the function exists up here, you technically don't need parameter names. However, I find it to be good practice to just put those, okay? Because you will need them when you actually define your function, all right? So double A, double B, okay? This actually needs something. We're just gonna return A plus B, okay? And then we got another one, double add, but this one's got an A. It's got a B, it's got a C, okay? And we're gonna turn A plus B plus C, okay? Now, if you like how fast I'm typing, highly suggest taking some typing, classes online for free. It, in my personal opinion, if, the faster you can type, the easier it can be to code, okay? So you can see here, I'm just gonna call those functions because they returned a double, and I'm crazy. I need to put values there, so 5.5, and let's do 4.5. And I shouldn't even be putting a plus there. I should be putting a comma. Okay. And then let's call the other one. Cout. Let's do add. Let's do 1.1, 2.2, and 3.3. We may not know what those answers are off the top of our head, but we certainly know they're different than each other. Okay. Okay. So our first one was 10, which is good. And then our second was 6.6. So we gave it the same exact function name, but a different amount of parameters, 3, 2. Now there is a little bit of wiggle room there. If you have the same amount of parameters, but you're sending different types. So if you do like an int and a string, and then like a string and then an int, those would technically be different, right? So that would work too, okay? Yep, that was the last concept. All right, so here's your quick code, everyone. We're just gonna call this one better functions, okay? Now that we really know how to do them, let's start writing some different types of things. So write 5 functions that have parameters and returns that accomplish these 5 tasks. So the first one, and you can see that I'm just listing now, return types, function names, parameters they should take, and what they should return, okay? And this is gonna kind of be how you're gonna start to see things listed out, all right? So if someone returns a true or false, it's called a palindrome, and it takes a word and it returns true if it's a palindrome, or it returns false if it's not. If you don't know what a palindrome is, it is basically a word that when rewritten backwards is the same word. So race car, if you spell race car backwards, you get race car. It's the same word. That's a palindrome. Well, at least I hope it is. And so when you do this function, there's some unique ways of accomplishing this. I don't want to really clue you into the way I did it. It was only I think 5 lines, maybe 4 lines of code. Okay, but I want to see what you guys do. The next one is int, get input string message. It returns an int from a user, just like the one I did in the video, except for with ints, not with strings now, okay? All right, and then we're gonna do a simple one, double max. It takes an A and a B double, and it returns which one is the max value. So if I send it a 5 and a 3, I should get back the 5. I should get the bigger of the 2 values. Now, I do not want you using the built-ins for this. You must manually figure out which number is greater and return the appropriate one. Okay, so you cannot use the built-in max function. And then D, bool check phone number. Okay, so it takes a phone number as a string. Do not get it as an int, okay? And it returns true if the phone number is correctly formatted. Fail. It returns false. Sorry, that's funny. It returns false if the phone number is not correct, okay? And this is the format that I mean. A parenthesis around the area code and a dash in between, these three and those four. Now, here's your advanced opportunity. Ensure that you only get numbers, okay? In this example, I just want you to check essentially that it is listed this way, not necessarily that it's a real phone number. So technically, characters might be able to pass. If you want an advanced opportunity, ensure that there are only numbers, okay? And that they're positive ones. All right, and then the last one is making one additional function that takes a parameter and does something and returns a value you're choosing. Basically, what I'm saying is pick a function that you've wanted to write to make the code you've been writing easier and write that function, okay? It needs to take info, it needs to return info. And don't just make it take a number and return the same number, okay? Okay. All right, now my quick code example is going to show you the check phone numbers and the palindrome. So let's get to that. Okay, so here we are. We're going to give an example of just those two things. So we're going to run our code. And would you like palindrome or check your number? So we're going to do the palindrome. What word would you like to check? Race car. And it is palindrome. Let's run it again with something that is not a palindrome. Like for abacus. Not a palindrome. Let's do it again, but with phone numbers. So we're going to type in a phone number. So 818-8181. Okay, so that is correctly formatted. You entered the correct number. Now, let's look at what is not a correct number. So let's just do this. Okay, you did not enter a correct number. Okay. Now, technically, the way that one is designed and the only extent that I'm asking you to go for is it should technically take characters. You enter the correct number because I'm really only checking this formatted correctly. We're going to leave it off of numbers for now. And the reason why is we're taking it as a string so that we can have these characters in here. And then you would need to really check each one of those to make sure they were an integer. It's a little bit more rigorous, so I'm going to leave it as an opportunity. So hopefully this helps you with the quick code a little bit and seeing what should be. This was not complete as usual. I'm showing more of the difficult stuff. But actually just this one little thing about this, palindrome, think for loop. Okay? Okay. All right, everyone. Hope you enjoyed it. See you next time.